All right, everybody say hi, Brooklyn.
Hi, Brooklyn.
They don't care about you.
I'm Jeff.
I care about you.
We have a couple of examples left to do in section 2-3 synthetic division. I have cut down the homework assignment for you guys. Let me write it at the top of this notes page. It is page, you gotta read, 171. And do numbers 12, 22, 30, 38, 56, and 60. Just those 6 problems for homework, okay, for section 2-3. There we go. All right, so on the last video that I did before we have come back, we have done Long's division and we've done synthetic division, okay? The next thing that we're going to talk about is the remainder theorem, okay? And this is going to give you a really nice way of checking your answer, okay? Use the remainder theorem to evaluate the following function at x equals -2, okay? So what I want to do is I want to take and I want to plug -2 in for each one of the x's. Okay, that's all I'm doing. Evaluate at -2. I'm just plugging -2 in for the x's. So I have, let me erase all that. I have 3 times -2 to the third power plus 8 times -2 squared. 5 times -2 minus 7. Okay, we're going to evaluate that, guys. So, what's -2 to the third power?
-2 to the third power?
Yes.
-8.
-8. Okay. 3 times -8 is -24. Okay. -2 to the second power is 4. 8 times 4 is 32, a positive 32. Okay. 5 times -2, -10, minus 7. Okay. I'm going to put all my negative numbers together. So -24, -10, that's -34, minus another 7. What's that? -41, right? Okay. And then plus 32. What's -41 plus 32?
Plus 41 minus 32.
-41 plus 32.
9.
-9. Okay.
Oh my
Now,
God, yes.
-9. This is what this means. Okay. This is the most important part for the remainder theorem. Okay. This is what this means. If I were to take this function right here and I would divide by, not x equals -2, but x plus 2, right? If x equals -2, then x plus 2 is the factor, right? If I would take this guy and I would divide by x plus 2, what would the remainder be? -9, okay? Let's do synthetic division. You don't necessarily have to write this down if you don't want to. I'm going to do it over here. I'm going to do it over here. So we have more room. Let's check to verify that to make sure that that is correct. So I'm going to put -2 on the outside here, and I'm going to put my coefficients, which are 3, 8, 5, and -7. And we're going to see if our remainder, when we do synthetic division, is -9, okay? First thing that I do, this is good review of synthetic division. First thing that I do is what?
Drop the
Drop the 3. Then multiply -2 and 3.
-6.
Is -6. Then add. 8 minus 6 is 2. -2 times 2. -4. 5 minus 4 is 1. -2 times 1. -2. And add those together. -9. Okay. So here is what would happen. If I would ask you on a test, synthetic divide this out. I want you to use synthetic division to divide this guy by x plus 2. Great, you've done that here, and this is what it looks like, right? You would drop 1 power, so it was x to the third power, now it's x to the second power. So 3x squared plus 2x plus 1 minus 9 over x plus 2. That's what he would look like. Okay, -9 was your remainder. To check your answer, I would always plug -2 into this thing, and you should get -9 as your answer. So that should be consistent. Whatever you get when you divide, if you plug that number in, should end up being the same as the remainder, yeah? That's a way of checking your answer to make sure it's correct. Now, you cannot do that with things like what we were doing before with the long division. Like this guy, there's nothing to plug in there. So that's kind of, like a weird thing. I cannot do that if I'm doing something that requires me to do long division. But with synthetic division, you can always check your answer, yeah? That's what the the remainder theorem says, yeah? Now, the next thing is the factor theorem. So if this is a factor, I'm just going to go down the example. Show that x minus 2 and x plus 3 are factors of this guy, okay? determine whether they are factors or not. If something factors into something completely, what is the remainder? So I want to look to see if the remainder equals 0. That's what I'm trying to see, right? Trying to see if the remainder is 0. So what I'm going to do is to see if x minus 2 is a factor. What are you going to plug in? Positive 2, right? X minus 2, you set it equal to 0, so x is equal to 2. If to see if x plus 3 is a factor, you would plug in x equals negative 3. Okay, so let's do that. Okay, 2 times 2 to the 4th power plus 7 times 2 to the 3rd power minus 4 times 2 to the 2nd power. Holy crap, minus 27 times 2 minus 18. Ugh, yuck. Alright, 2 to the 4th power is 16 times 2 is 32. 2 to the 3rd power is 8 times 7 is 56. 2 times 2 is 4 times 4 is 16, so minus 16 we're plugging 2 in to see if it comes out to be 0. Negative 27 times 2 is negative 54 minus 18. Does that come out to be 0?
No.
I don't know. 32 plus 56 minus 16 minus 54 minus 18.
0.
0. Great. Okay. Now, does negative 3 do the same thing? If we plug negative 3 in? We'll find out. Let's plug negative 3 in. So 2 times negative 3 to the 4th power plus 7 times negative 3 to the 3rd power minus 4 times negative 3 squared. I'm running out of room. Minus 27 times negative 3 minus 18. I think it comes out to be 0. I think it comes out to be 0. Sure. To the 3rd.
Is this not really real?
Wrong.
Wrong?
You did get a couple wrong.
It equals 0.
It equals
On the
0.
website,
Great.
Yeah, I got them wrong
Great.
because I told you what I'm doing.
Okay. Alright, now, this is the stinky part. Are you ready? Find the remaining factors.
This is the wrong one.
Okay.
and then-
So I know.
There's no remainder. There's a 0.
Okay, so I know that x minus 2 goes in there perfectly and x plus 3 goes in there perfectly. How many factors will he have? In the
This
very,
is
very end.
easy.
4.
4, because he's x to the 4th power. They have listed 2 of them. How can I find the other 2 factors? How can I find the other 2 factors?
I don't know, man.
I know that x minus 2 is a factor and I know x plus 3 is a factor. How can I find the other 2? There are 2 left.
Make the other ones negative 2
Plus and minus 0.
Divide by x plus 3.
Let's divide these guys out and figure out what's left over, right? And then break him down, okay? So, which one would you like to divide by first?
Love you.
Ooh.
The 2? Should we synthetic divide or long divide? Of course, synthetic always, if you can, right?
Oh my god.
So let's divide the 2 out. So we're going to set 2 on the outside.
7.
So 2, you said 7. Do we need to put zeros in there?
No.
Always check to make sure.
Negative 4.
Negative 27, negative 18. Okay. So drop the 2 down.
Yeah, I missed it. It's not there. Put skip it. I was like,
Yeah, I was like,
What?
I was so triggered on that question where he said,
Oh, I
put a 0 or skip it. I was like, you don't
Yeah.
just skip it.
You don't just skip it.
Yeah.
You're just
I
like,
was
"Be in the
like,
world."
You should have seen. I was up real late one night doing geometry videos, and they're doing proofs right now. And I was trying. I'm like, how do I embed questions into a proofs video? This is terrible.
Wow.
And so I was drawing a blank, and I'm like, what do I put here? Like, okay, so I'll put like, we'll go through a proof, and I'll get to a point where I'm gonna ask like, what do you put for the reason section? You know, the right hand column. What do you put for the reason? And I was like drawing a blank, and so I put the correct answer, and then I put because it is. Because I said so. Like, I put, like, really obvious wrong answers, right? I'm like,
If you
this
get
is
it
late,
wrong.
you basically get a free point. I don't know. I don't think they did. Anyway, so that was kind of free points for them. All right. 4,
11.
11,
22.
22,
18.
18,
I
32.
forgot five.
No, 36.
I don't
36
know.
minus 27,
Yes.
9.
9,
Oh my gosh.
18.
0.
We knew that that 0 is going to happen. We've already plugged it in. We know that 0 is going to happen. Okay? Now, we're going to do a double synthetic division. So I'm just going to branch off of those numbers as well. Okay? And we're going to do -3 here. Okay? Now, where should the 0 go?
Leave it.
No.
I don't know.
This guy should end up being 0, right? For below the next one. Okay? Drop the 2 down.
-6.
-6.
5.
5.
-15.
-15. 3. -9.
0.
0. Okay, now, what is this guy look like?
That's our thing.
That's our thing. But what is what?
2x cubed.
Is it x cubed or x squared or x?
cubed.
It is x squared because we took it
so
x to the 4th
-3.
power, right? This was x to the 4th power, and we've divided twice. So this is an x squared plus 5x plus 3. That's what he is, yeah? Okay, now we need to break him down one more time. I need to break him down. How do you break that
6.
thing down?
Do 3
He
and
is a
2.
He is a
Complex
trinomial. 2 times 3 is
6.
6. What multiplies to get 6, but when you add them give you 5? 2 and 3, okay? So, 2x squared
Plus 2x.
plus 2x
Plus 3x.
plus 3x plus 3, yeah?
I got a 2x. You got x
Okay,
plus
are we good?
1.
Now we do the parentheses, right?
Plus,
Break,
plus,
okay? 2x is what we're going to pull out. So, left over
x
is
plus 1.
x plus 1.
And then take out 3.
They got a 3,
X plus 1.
x plus 1, okay?
X
So,
plus 1 and 2x plus 3.
X plus 1 and 2x plus 3.
And x equals -1 and -3 over
X
2.
equals -1 and x equals -3/2. Okay, let's look at the question though. Let's look at what they were asking.
Those are the other
It
two.
says find the remaining factors. So if we want to factor that guy completely down, he would be the factors x minus 2, x plus 3 were the ones that they gave us, right? And then x plus 1 and 2x plus 3 were the remaining factors. That is him completely factored down. The ones that we had to find were these two guys, right?
Where'd you get 2 on the first one?
What do you mean how
They
they
gave you
get
2.
Oh, they gave us the first
They
two.
gave you the first two.
They
right?
gave us the first two.
The
right?
x minus
They
2
said,
and
No,
show
no,
that-
no. Go on. Why is the 2 mentioned?
Because that's just always the first step.
You just drop it.
You drop the 2 down, and then you multiply, and then you add, then you multiply, and then you add, then you multiply, and then you add.
Wait, go back down to the 40 first.
Okay.
Okay. I didn't know
So
if I
when
had
it says find the remaining factors, you're just trying to find these guys. You don't have to set them equal to 0 like we did. Okay? All right? So this last little box says uses of the remainder theorem in synthetic division. If the remainder is 0, you know that he is a factor, right? If your remainder is 0, if when you plug it in it comes out to be 0, then you know that that is a perfect factor of the thing, right? Whatever you're dividing by. Okay? So that was all that we had left to do. Good?
No.
Alright, so with whatever time is left, I don't know what time we get out of here. There are 6 problems. Those are your 6 homework problems. That's it.
Thank you.
Okay? Everybody say bye, Brooklyn!
Bye, Brooklyn.
Wow.